Bismillahirrahmanirrahim and Assalamu alaikum. Welcome to my channel, and today we are going to learn about subprograms, built-in functions, user-defined functions and subroutines. A large program is divided into smaller manageable parts called subprograms or modules. It is designed to perform a specific task and return a value. It is also called a function. A function has the highest priority in the statement, so it would be evaluated before anything else in the statement. There are two types of subprograms: built-in functions and user-defined functions. Built-in functions are also known as standard functions, library functions, or intrinsic functions. The built-in functions are written by the language developers and incorporated in it. Incorporated means made part of it. These can be used by calling them. The call function will have a specific name followed by a parenthesis. An argument is passed inside the parenthesis. An argument is the value or values on which the function is operating. The argument may be constant, variable, expression, or another function. The syntax of built-in function is line number, function name, and in parentheses, the arguments. Where function name is a valid GW basic function name, and the arguments are the values on which the function is to be operating. There are two types of built-in functions: numeric functions and string functions. As the name indicates, these functions are applicable on numeric values, only numbers, and produce the numeric results. We are doing the following numeric functions in today's lecture: ABS, absolute, int, integer, RND, random, log, logarithm, and date. Where ABS stands for absolute, it returns the absolute value of an expression that is without any sign. Syntax is ABS and in the brackets the value on which the ABS is operating. Example is print ABS minus 45. You can see the output. It is 45 without the negative sign. Second line is ABS minus 67.2. Again in the output, the 67.2 is without any negative sign. In line number 30, ABS plus 23. Again in the output, the 23 is without any positive symbol. Int stands for integer. Syntax is int and in the parentheses the arguments. For negative number, it returns the lowest integer less than or equal to x. For example, if I say print int minus 67.3, it will return me the next lowest digit, that is minus 68, regardless of the rounding off rule. And print int minus 67.8 will return minus 68. For positive number, it truncates the decimal part of the number. Truncates mean removes. Print int 34.8 will return 34 and print int 34.2 will return 34. For whole number, it returns the same number. Print int 45 will give me 45 and print int 345 will return 345. RND stands for random. Syntax is RNDX. It generates a random number between 0 and 1. If I say print RND7, it will generate a random number between 0 and 1, and similarly for print RND40. It generates the same number until the value of x is reseated. Means that if we change the argument, then it will change the value, otherwise it will repeat the same value. You can see the example here. I say print RND50, it has generated 0.1213501, and if you continue running the program again and again, it will repeat the value until and unless you will change the RND50 to RND something else. If x is equals to 0, then the last number is repeated. You can see in this example, if I say print RND 0, again it will be repeating the same number. Log is logarithm. It returns the natural logarithm to the base e 2.718282. Syntax is log x, where x is the argument. Print log 10 will return 2.302585, the natural logarithm of 10. $. It is used to set or retrieve. Retrieve means to get the current date of the system. Syntax is $, or $, equals to $, where $, is the string. If I say print $, it will give me the current date of my PC. And if I set the $, as a string and give the date myself, then it will say OK. If you print the date again, it will give the date which you have entered recently. Now, string functions. These functions are used to process character strings and produce numeric or string values. We are going to do the following string functions in our today's lecture. Well, $, LeftDollar, RightDollar, and CorrectDollar. Well stands for value. Syntax is well $, where $, is the string argument. It returns the numerical value of the string if the number is written in the start. For example, if I say print val 78 City Lahore, then it will return me 78. It removes the leading blanks, tabs, and line feeds. For example, if I write some spaces in the string in the start, then it will remove these spaces and return 92. If first character is not numeric, then it will return 0. Like in this example, if I say print val pk47, instead of 47, it will return a 0. $. It returns the requested part of the string. Syntax is $, string nm. It returns a string of length m characters beginning with nth character. For example, if I say print $, Pakistan 63, it will start from the 6th character of the given string Pakistan, which in this case is T, and will count the next 3 characters and will print those characters, TAN in this case. Print $, Pakistan 14 will return PAKI starting from the first characters, and it will print the 4 characters. If m is omitted or if fewer characters are to the right of n, then all characters starting with n will be returned. For example, print $, Lahore 4. There is no n, so we are going to start from the 4th character, which is in this case is O, and return all the remaining characters. Similarly, for Lahore 110, it will print the whole Lahore. If m is equal to 0 or if n is greater than length of string, then it returns a null string. Like in this case, print $, 4 and 0. Nothing to be printed. Similarly, print $, Punjab 73, because all the characters are total 6 in Punjab. If we are going to start with 7th, there is nothing to print. Remember that n and m must be in the range from 0 to 255 characters. The next function is $. Syntax is $, string n. It returns the specified leftmost characters of a string. For example, if I say print $, Pakistan 3, it will count the leftmost 3 characters and print, in this case, PAK. If n is greater than length of the string, then entire string is returned. For example, if I say print $, Pakistan 10, the total character in the string Pakistan are 8, but here I am giving it the value 10, so it will return the whole string. If n is equals to 0, null string is returned. Just in this case, print $, Pakistan 0, not to print anything, and it will return a null string. Remember that the value of n must be in the range of 0 to 255. RightDollar. Syntax is RightDollar string n. As the name indicates, it returns the specified rightmost characters of a string. Print $, computer 3 means that the last or the rightmost characters ter would be printed. If n is greater than in length of the string, then the entire string is returned. Just as in this case, print $, computer 10 will return the whole computer string. And if n is equals to 0, null string is returned. As in this example, print $, computer 0 means null string would be returned. Remember that the value of n must be in the range of 0 to 255. The next function is CorrectDollar. It is used to convert an ASCII code to its character equivalent. Syntax is $x. If I say print $65, it will return me A, capital A, because ASCII code of capital A is 65. If I pass 97, then it will return me small a. On the opposite, we use ASC, the ASCII function, to return the ASCII code. If I pass a character in the ASCII function, it will return me 65. And if we'll pass the small a, then it will return me 97. The next very important concept is user-defined functions. A user-defined function is completely defined and customized by the programmers. That's why these are called user-defined functions. These functions return a single value, also referred to as procedures. A user can define the function with def fn statement. These functions are defined only for the life of a given program and are not part of the basic language. A single line function can be defined by def fn statement and can be used more than once in the same program. A user-defined function may be defined more than once in a program by repeating the def fn statement. Def fn statement is illegal in direct mode. Recursive functions, loops are not supported in def fn statement. The syntax of user-defined function is line number, def fn, name of the function, arguments, expressions. Where def fn are the keywords, name is the valid name, arguments are the values or variables on which the function is to be operated. An expression is a single line function or operations definition. There are two types of user-defined functions, numeric functions and string functions. The errors which can occur in user-defined functions are type mismatch error. If a type specified in the function name does not match with the argument type, then type mismatch error will occur. Undefined user function. If a user-defined function is called before the execution of def fn statement, means that before the definition, then undefined user function error will occur. Let's check out an example of user-defined functions. I'm going to define a functions def fn sum x equals 2x plus x. Def fn are the keywords, sum is the name of my function, and x is the argument or a numerical value, and the definition says that x will be added in x itself. Let's take a number from the user, which is a, and we can call the function like it is written in line number 30. Print double of your number is fn sum. This is the function call, and this time I'm going to pass the argument, the value which the user has provided, and simply end. Execute the program to get the output. First it will ask the number, enter a number, we will enter 5, then it will show us double of your number is 10, means that 5 is added in 5 according to the definition of fn sum. Let's check out another example. Here pi is 3.14 You can guess what I'm going to do. Def f1 area x is equals to pi into x raised to the power 2. I'm going to calculate the area of a circle pi r square. Remember, here the function name is area. I'm going to pass the argument x as radius of that circle, where pi value is fixed 3.14. I'm going to take the input from the user as enter radius of a circle r and print. Here I'm going to call that function which I have made to calculate the area, fn area, and here I will go for the value r, the radius which the user has entered, and execute the program. Enter radius of a circle. I'm giving it 20. It will return me area of circle is 1256. If I say 4.5, the radius of the circle, then it will return me area of the circle as 63.58501. Let's check out another example of user-defined function, this time a string function. The definition of my function says def fn name dollar x dollar plus x dollar, means that name dollar is the name of the function, x dollar is the string which is passed as argument, and it will concatenate my string by x dollar plus x dollar. It is not adding up, it is just concatenating, means that combining both strings. Let's take out the input from the user, enter your name and dollar, and here we can call the function like print your concatenated name is fn name dollar n dollar. What it will do if I'm going to execute the program, enter your name. If I say DPS, then your concatenated name is DPS, means that it has combined the string. The next very important topic is subroutines. Subroutine is a self-contained set of statements that can be used from anywhere in the program. Unlike a function, a subroutine has multiple statements. A subroutine performs its specific task and then returns control to the part of the program that calls the subroutine. The designing of subroutine is more easier than function. It can be referenced, means that it can be called from anywhere in the program. A subroutine is not given a name like a function. It can be used to determine more than one numeric or string quantity. It can be called multiple times in a program, even from another subroutine. This is called nesting, and it only depends upon the memory. These can appear anywhere in the program but readily distinguishable from the rest of the program. To branch to and return from the subroutine, we use the following statements: goSub return and on goSub. Let's check out the example of subroutine. Here in line 10 it's written print going to subroutine colon goSub 40. Two statements in a single line separated by colon. Print going to subroutine is mentioning just printing going to subroutine, and goSub 40 will actually take us to line number 40, means that a subroutine is written over there. Line 20 is print back from subroutine and 30 end. Line 40, where our subroutine is going to be started, written over here is print I, print love, print Pakistan. These three statements are the part of subroutine. I have just written here three print statements. You can do anything over here because a subroutine contains multiple statements in multiple lines. You can use functions, you can use recursive function, you can use loops or any other thing. Line 70 will take the control back to line number 20 and print back from subroutine. Let's check out the output. When I execute the program, it says going to subroutine, I love Pakistan, and back from subroutine.